Hello, this is a bite-sized presentation on memory and CPU usage in the object server in Netcool Omnibus version 7 in a 32-bit environment. The object server uses data storage called Memstores. There are hard and soft Memstores. Hard Memstores are disk-based. Soft Memstores are memory or RAM-based. Memstore allocation is set on the object server's creation, although these limits can be increased afterwards. The object server must be shut down to alter the table store hard limit, and the soft limit cannot exceed the hard limit. In general, increasing the Memstore size is not required, as it is better to minimize table usage, keeping data retention to a minimum. The object server process takes memory on startup relative to the allocated soft and hard limits. Its other memory usage is made up from the number of clients connected and the active selects. For example, the default object server will be using 115 megabytes and reserve 922 megabytes of RAM. If the hard limit is increased to 1 gigabyte, the object server will be using 179 megabytes and will reserve 1.4 gigabytes of RAM. Because the object server is a memory resident database, the reserved memory should always be available as physical RAM. Clients are allocated memory upon connection. Clients increase object server memory as they perform selects on the object server. The object server and gateways do not release memory after they have finished with it. This means the reserved memory will increase with the number of clients and select sizes and not be reduced until the process is restarted. Triggers affect memory usage as they perform selects on tables and use the internal temporary tables. It is therefore important to test trigger customizations and observe memory usage. A generic clear uses a temporary table and performs table scanning of the alerts.status table, which can grow in size. The generic clear trigger can therefore be responsible for increased memory usage. Always ensure that dynamic tables such as alerts.status are kept to a minimum size and are actively maintained. The trigger statistics log file can indicate problems with triggers. Actively monitor and react to increased trigger profile usage and examine the impact on the object server and its users. The log file can manually be checked, otherwise custom self-monitoring triggers can be used to warn the administrator or respond to unexpected trigger usage. Sometimes an object server can become locked due to excessive table store usage. This can be due to custom triggers or just an excessively large alerts.status table. To recover the object server, you can place it into single user mode by making the object server's port unknown to external clients. Starting the object server with the command line option -auto-enabled false prevents the triggers from acting on the data. This allows the object server to be purged of unwanted data and for problematic or suspect triggers to be disabled before restarting the object server as normal.